Okay, somewhere Andreas is freaking so hyped that I'm about to talk about this kind of stuff. The holy grail of neuroscience. Researchers create stunningly accurate digital twin of the brain. Yeah, this is the beginning. You know, altered carbon. We were kind of talking about that the other day with the bodyoids, right? Because they're trying to make physical twins of people for harvesting organs and all this stuff. And this was just like the other half. In a breakthrough that could revolutionize neuroscience, researchers have harnessed the power of artificial intelligence to create a highly accurate digital twin of the mouse brain. This advanced AI model can predict how neurons respond to entirely new visual stimuli, something no previous model has accomplished with such precision. Recently published in Nature, the study, led by scientists from Baylor College of Medicine, Stanford University, and Allen Institute for Brain Science, introduces a sophisticated artificial neural network called a foundation model. The model replicates brain activity and mirrors the intricate structural details of neural circuits, offering a powerful new tool for exploring the brain's inner workings. Much like how ChatGPT and other large language models transformed natural language processing, this brain model could reshape how we study perception, behavior, or even consciousness. If you build a model of the brain and it's very accurate, that means you can do a lot more experiments. Stanford professor of ophthalmology, is that like of the brain? Hold on, let me just real quick do this and do that. Field of medicine treating eye disorders. Okay. Isn't that optometry? Anyway, okay. So interesting. All right. So but they're talking about the brain, but it's about the eyes. I guess it's all in the same zone. Senior author of the study, Dr. Andreas. Shout out to Andreas. He's there. Tolias explained in a press release, "We're trying to open the black box, so to speak, to understand the brain at the level of individual neurons or populations of neurons and how they work together to encode information." That is really the key, isn't it? For decades, decoding the brain's language has been one of science's most enduring puzzles. Traditional neural network models, often trained to respond to specific data sets like object recognition tasks or motion detection, performed well, but only within their comfort zones. These models struggle once unfamiliar data is introduced, such as new types of images or stimuli. Inspired by the power of foundation models in AI, large-scale models trained on massive data sets that generalize remarkably well to new domains. Neuroscientists set out to create something similar for the brain. They recorded real-time neural responses in 14 awake mice as the animals watched natural videos and interacted with their environment. It's very hard to sample a realistic movie for mice because nobody makes Hollywood movies for mice. Okay. However, mice like movement, which strongly activates their visual system. So we showed them movies that have a lot of action. These recordings captured visual stimuli, behavior like eye movement and pupil dilation, and contextual variables across 6 visual brain areas. Over 900 minutes of data from the mice watching clips of action movies such as Mad Max were fed into an artificial neural network. They call it AN. The results was a 4-part model, a perspective module to account for how a mouse's eyes can see stimulus or sees a stimulus, a modulation module for to interpret behavioral signals, a core that processes the bulk of the sensory data, and a readout that translates that data into predictions of neural activity. Trained on just 8 mice, the model proved startlingly robust, accurately predicting brain responses in new mice and across novel stimulus types it had never seen before. The crown jewel of this AN is what researchers call the foundation core. Once trained, this shared internal representation of visual processes that could be transferred to new individual mice with minimal additional data. Whoa. What does that mean? Once trained, this shared internal representation of visual processing could be transferred to new individual mice with minimal additional data, sometimes as little as 4 minutes of new recordings. This dramatically reduced the amount of real-world data needed to accurately model a new brain. Oh, okay. So it's a foundation. So when they hook up a new brain, they could map it much faster because they have like the baseline down. Okay. Compared to previous leading models, the new foundation model achieved a 25 to 46% improvement in predictive accuracy, even in notoriously complex higher order visual areas of the brain. These performance gains represent a blueprint for developing increasingly accurate models of the brain that can adapt quickly to new data without starting from scratch. Remarkably, the model didn't stop at predicting how neurons would fire. It also inferred their physical characteristics, like where they sit in the brain and what kind of neuron they are. In another major leap for neuroscience, researchers with the Microns project recently unveiled the most detailed functional map of the brain to date, offering. Okay, I want to actually see that. Let's see what that looks like. Do they have a picture of it? I guess it's probably multiple pictures, huh? Bum.
One byproduct of this whole project is just how incredibly beautiful the brain is and how this project kind of creates this high resolution map. Just looking at these neurons shows you their detail and
Okay, these
scale
are
in a way that
different
makes you
neurons.
appreciate the brain with a sense of awe in the way the size of the grain of sand, but actually contains almost 100,000 neurons, 4
Whoa.
kilometers of axons linking these neurons,
This
and
is a
in
cross
the
section of a
initial
brain.
synapses or connections between these neurons. This project, started with the team at Baylor.
That is fascinating. Okay, I want to read more into that. Okay, let's see. This feat was once considered impossible. Wow. Using data from the Microns project, researchers applied their model to more than 70,000 neurons. The model accurately predicted anatomical cell types, dendritic structures, and even synaptic connectivity patterns, despite never have been trained on anatomical data. Wow. This suggests that the functional barcodes generated by the model, essentially how a neuron uh, processes processes. I read so many words and then I got stunted on an easy one. Anyway, how a neuron processes visual information can be used as fingerprints to reveal a cell's type and structure. This is so much more than just mapping the brain. A key advantage to creating a digital twin of the brain is its scalability. Because of the model can simulate neural responses inside a computer, researchers can now run unlimited experiments that would be time-consuming, invasive, or even impossible to perform on living brains. Now imagine, and they're doing this, they're using living brains to create computers. I'm not joking. So with this combined, I mean, artificial intelligence and robots of the future, like we are very quickly coming to a point of no return. And Elon Musk talks about it often, actually. Like AI could we man, this is insane, actually. Not only, altered carbon, it kind of plays with the whole artificial intelligence more in season 2, with one of the best characters from season 1, the bartender or hotel, I don't know, bellhop guy that the artificial hologram guy. Loved him. Awesome. He was in season 2. Season 2, it was more like his trying to find out who he is, because he kind of gets all messed up. Anyway, That's like the only redeeming part of season 2 is because he was in it. Anyway, for example, researchers tested how digital brains responded to classical visual experiments like moving dots, Gabor patches, flashing lights, and found that the digital neurons exhibited the same orientation or spatial selectivity as their real counterparts. In one test, simple simulated neurons matched the actual preferred orientation of live neurons within just 4 degrees, but not exact, huh? Okay. An extraordinary degree of precision. I mean, that's still pretty insane. By leveraging similarities between brains rather than treating each one as a separate puzzle, researchers can now model shared cognitive features while still accounting for individual quirks. Yep. Man, they're advancing to understanding how the movie Transcendence. I'm sure there's plenty of movies about this too, where humans upload their consciousness into a computer. The Matrix. I mean, it's coming. It's crazy. Additionally, what makes this recent breakthrough stand out isn't just the technical prowess, it's the philosophical leap. Foundation models, by their nature, don't just memorize, they internalize general principles. The hope is that a similar approach in neuroscience could eventually uncover a universal set of rules that governs how all brains process information. By uncovering a shared set of rules that govern how neurons encode, process, and transmit information, scientists could be on the verge of establishing foundational laws of neuroscience, akin to the laws of physics that govern the natural world. Wild. I mean, they're basically marrying biological brains and digital brains with this information, with what they're doing. They're being able to actually mimic like actual brain waves. It's going to create an artificial intelligence that is essentially humans, like not humans, right? Obviously, they can never be human, although who knows, right? I mean, are we living in a simulation? Is this just another? Are we going to like create the next level, the next iteration of a simulation? Who knows, right? It's crazy. I'm a gamer. I'd enter the Matrix and find a way to break the game. Good for you. Love that energy. Just as equations like Newton's laws or Einstein's theories of relativity provide a framework for understanding motion and energy across the universe, a universal neural code could offer a unifying theory for how brains function across species, individuals, and contexts. Such a discovery would revolutionize our understanding of cognition and behavior and lay the groundwork for prediction, standardized models of brain activity, ushering a new era in neuroscience and also control. Our present foundation model is just the beginning, as it only models parts of the mouse visual system under passive viewing conditions, researchers wrote. As we accumulate more diverse, multi-model data encompassing sensory inputs, behaviors, and neural activity across various scales, modalities, I've never seen that word before. Modalities and species. Foundation neuroscience models will enable us to decipher the neural code of natural intelligence, providing unprecedented insights into the fundamental principles of the brain. Now, this, of course, is just on mice, but it's only a matter of time before it gets to humans. Well, that's a good question. Who funded this science, right? S90? Who funded this? It's, to me, I'm assuming there's more billionaires maybe than ever now, right? And the older these people get, the more obsessed with staying alive they are, right? And they don't want to die. They're trying to create gods. That's kind of where I'm going to with this, okay? Like in Altered Carbon, to just keep in tune with that, they have what do they call the elites? I don't remember exactly what they call it. It's been a long time, but they're these people that have been around for thousands of years because they're just taking their brain meths, right? Thank you, King. And they're putting it in a new body. They just stay young forever and then they never die because their consciousness is in a code, the stack, and then they're putting it into a new sleeve whenever they feel like it. Whenever the sleeve's starting to age, whatever, they just get a new, younger, hotter sleeve, whatever. And then they lock in control of everything. The season 1 was so good of Altered Carbon. It's really a shame season 2 went downhill as far as it did. Let's see here. The success of this model raises significant questions about the future of neuroscience and the ethical and philosophical implications of simulating brains with such fidelity. Could similar models one day simulate the human brain? Could they lead to better brain-computer interfaces, more accurate diagnosis for neurological diseases, or even a deeper understanding of consciousness? Or I mean, they mention neurological diseases, but not just diagnosis, but like a way to fix them. I mean, I'm shocked they didn't actually put that on there. The researchers caution that we're not there yet. Their digital twin, brain twin, currently applies only to mice's visual cortex under passing viewing conditions. But the groundwork has been laid for a much broader project. Yeah, exactly. This is exactly what I've been saying. Ultimately, in the same way that large language models unlocked new capabilities in artificial intelligence, this digital twin of the brain could unlock new frontiers in biology, medicine, and cognitive science. And in doing so, it brings us a step closer to answering the enduring mysteries of the brain. In many ways, the seed of intelligence is the ability to generalize robustly. Yeah, I like that. The ultimate goal, the holy grail, is to generalize to scenarios outside your training distribution. Okay, I don't like how this person just went there with that. It feels like sacrilege. I'm not the most religious here, so I'll let you decide. Eventually, I believe it'll be possible to build digital twins of at least parts of the human brain. This is just the tip of the iceberg. There it is at the end. There it is. Dr. Tolias gave us a little glimpse of what they actually want to do. Of course, that's the end game. Of course. They want to live forever. That's what this is about. Of course. Not, better brain computer interfaces. Sure. Yeah. Okay. That's what you're telling. But it's like, no. You want to upload your consciousness into a computer and live forever. That's what they want.